Assalamu alaikum. Uh, this is our project, MES project, where we develop our Arduino compatible boards and successfully deploy on hardware. So now I explaining how I make this and what is the main components of this hardware and what we need, what we did. First of all, what if you could build your own Arduino from scratch? No off-the-shelf board, just raw component and a custom PCB you design yourself. That's what we exactly did. This is our layout, PCB layout. This is our 3D visualization. You can see some components is not visible here, but this is here the components are visible in this schematics. This is our custom Arduino compatible board designed as a part of our microcontroller embedded system course at Yale University. The brain of this board is the Atmega32 8P, the same chip that powers the Arduino Uno, running at 16 MHz with an external crystal oscillator. Now the key components. We start with the schematic in Proteus. The board has 2 voltage regulator. 5-volt rail and 3.3 rail for powering the microcontroller and polarity protection. A reset circuit with a pull-up resistor and decoupling capacitor across all power pins. This is our 2 voltage regulator with the decoupling capacitors. Then we move to the PCB layout. This is a single layer PCB board. All traces routed on one copper layer, measuring roughly by 60 to 68 by 65 mm. Every input-output pins of the Atmega32 is broken out to start at 2.54 mm header, just like a real Arduino, same as regular Arduino. And yes, our team name is etched right into the silk screen. So now we see the bills of materials. Here is the bills of material. You can see here. The board uses 20 components in total, 25 components in total with capacitor, resistors, decoupling with 22 picofarad capacitor, 400 nanofarad capacitor, and C4 SMD components, SMD capacitor, 10K resistors and 330 ohm resistors. One use and 4 IC use. One is Atmega32, one is crystals, for oscillator ICs, and other is envelopes. To prove our working, this is the diode. This is the diode that we use, and no transistor use, and other junctions, other boards, headers and female and male headers were used. Now when we see the schematic capture, here we see a small small Arduino power output pins where we directly connected by a battery. See, and this is our Atmega chips. Here the capacitor of 100 nanofarad is, and a small reset switch is connected here. And this is our digital pins, and this is our analog pins. You can see here analog pins and digital pin also. This is a female connector, females connectors where same as like Arduino boards. And this is our 16 megahertz frequency crystals that produce clock signals. This is our hardware. Now when we see the hardware, we traces all the components perfectly with same as the original Arduino. With this board is completely Arduino compatible board. When we see this in 3D visualization, you can see all board is same like is Arduino, but some ICs are missing because of there is no 3D layout is available. 3D footprint is available in the Proteus. So but this board is same as the Arduino board, original Arduino board.